Welcome to question 9 from the 2020 TMUA paper 1. The question gives us the quadratic x squared minus 14x plus 9, and we are told that it factorises as x minus alpha times x minus beta, where alpha and beta are both positive. Using this information, we are asked which quadratic can therefore be factorised as x minus the square root of alpha times by x minus the square root of beta, and we are given 6 different possibilities. Pause the video here, read through the possibilities, and have a go at answering this question for yourself. Okay, well let's begin by looking at this quadratic. Since we're told it factorises as x minus alpha times x minus beta, we know that these two expressions must be exactly the same. So let's expand out x minus alpha times x minus beta, and that gives us x squared minus alpha plus beta times x plus alpha beta. And since these two expressions are exactly the same, we can therefore compare the coefficients, and we see that therefore alpha plus beta must be 14 and alpha times beta must be 9. So this gives us two equations with two unknowns. So perhaps what we could do would be solve for alpha and beta, and then square root them, and then expand out the expressions x minus alpha times x minus beta and find which of these quadratics we get. However, this seems like it has a lot of steps to it, and one of the skills we want to hone for the TMUA is speed. So what other method could we do? Well, we could try just directly expanding out x minus the square root of alpha and x minus the square root of beta, and see if we can relate what we find there to these two equations directly. So let's do that. If we expand out these two brackets, we get x squared minus square root alpha plus square root beta times x plus square root alpha beta. And then directly we can see, well, square root alpha beta we can find just from alpha beta must be square root of 9, because alpha beta is 9, and that's just equal to 3. So we straight away know the constant term is 3, so that tells us straight away that we either have option A, B or C. But how can we find square root alpha plus square root beta? That's not a particularly nice expression, and it doesn't seem to follow from alpha plus beta or alpha times beta. Well, since we have lots of square roots in this expression, both things are square rooted, let's instead think about squaring it. What's that equal to? Well, just algebraically, if we square this, we get square root of alpha squared, which is alpha, plus 2 times the product of these things, plus the square root of beta squared, which is beta. And we know what alpha and beta are, and we've just found the square root of alpha beta is 3, because we know alpha beta is 9. So we can rewrite this as alpha plus beta is 14, and 2 times square root alpha beta, 2 times square root 9. Square root of 9 is just 3, so 2 times square root 9 is 6, so 14 plus 6 is 20. So we know that square root alpha plus square root beta all squared is equal to 20. So therefore, if we square root both sides, since we know this is positive, we have square root alpha plus square root beta is equal to square root 20. So therefore, the equation with roots square root alpha and square root beta that we find by expanding out x minus square root alpha times x minus square root beta is x squared minus square root 10 to 20x plus 3. So we now have the equation, and if you check the options up above, then we can see that that is option C. So our answer is C.